These are the solutions to the last quiz. This was one of the more difficult quizzes. So we start off, we know that the true percentage of people in the U.S. who drive Hondas is 31%. So this is telling us that the true population proportion, P, is equal to 0.31. And now we're told we take a sample of 900 people and we find the percentage of people who drive Hondas from that sample. What percentage, the percentages would come from what sort of distribution? Well, the central limit theorem tells us that the sample proportion for large samples is going to be distributed like a normal random variable. Its mean is going to be the true mean of the population, and its standard deviation is going to be P times the quantity 1 minus P over N square root of the entire quantity. Okay, and so the short answer here is we could just say normal. I would accept normal, or I would accept this. Either one is fine. Let me write the answers that I'll accept in red. So you could just say normal. But if you wanted to be more specific, you could give the exact distribution. What would the mean be? Well, the mean would be the true population proportion. So it would be P is equal to 0.31. And what would the standard deviation be? Well, we know that the standard deviation of P hat is given by P times 1 minus P over N square root. So P here is 0.31. 1 minus P is 0.69. I'm going to multiply them, divide it by 900, and take the square root of that whole quantity. And when you do that, and I'll just do it really quick here on Excel. Okay, 0.31 times 0.69 divided by 900. And that ends up being 0.015. Okay, 0.0154. That's the standard deviation. Okay. And this is in probabilities. This is not in percentages. So now we want to sketch a distribution. Well, we know that the mean is always at the center. And I'm just going to add 0.015 to this. So this will be 0.325, 0.34, 0.355, 295. I'm going to subtract off 0.015. Okay. 80 and 0.265. And so my distribution then should look like this. It dies down after 3 standard deviations. Okay. So I'm going to use the fact here that the mean of P is 0.31. I'm sorry, the mean of P hat, is 0.31. The standard deviation of P hat is roughly 0.015. So I'm just going to step out in units of 0.015. And really I should put P hat here down in the x-axis. All right. So the key is really knowing this fact right here. This is what we call the central limit theorem. Let's take a look at the next problem. So here it says that you're the president of Acme Stapler Corporation. Your company's had 70% of the market on staplers for a long time, but you feel that sales are slipping. And you might be losing some of the market. You tell one of your workers to go take a survey of local stores to see what percentage of their staplers sales are from Acme. He visits 400 shops and finds that 62% of these stapler sales at these stores are from Acme. Okay. So if the true percentage was 70%, what is the probability that you could have obtained a percentage of 62 or less? Well, if we think about it for a second, right, we know that P hat, so this is what we know from the central limit theorem. we know that p hat has a normal distribution with mean p and standard deviation p times 1 minus p over n. Well, p is a true population proportion, which in this case is 0.70. And so if we put all this in, we also have a sample size of 400. If we put all this in, this tells us that p hat has a normal distribution with mean 0.70. And when we put all this in here, let's see, we're going to get 0.7 times 0.3 divided by 400 and take the square root of that. And we end up getting 0.022. Okay. And now this is just like any other normal distribution problem. I know the mean, I know the standard deviation, I can tell the percentile of 62. So I'm going to go ahead, I'm going to use the fact that my data value is 0.62. I'm going to convert that to a z-score, which is the data value minus the mean divided by the standard deviation. And when you do that, you get minus 0.08 divided by 0.022, and this ends up being huge. Actually, it's 0.022, sorry. Okay, this ends up being minus 34.91. It's not even on the charts. Okay, this is the z-score. When you go to the charts, you find out that the very smallest this can be is 0.35th percentile. So the probability is less than 0.35%. It's very, very low. All right, what is the margin of error? Well, the margin of error is always the same formula, right? It's just going to be 100 divided by the square root of n. In this case, n is 400, so it's going to be 100 divided by 20, or 5%. The confidence interval, so a lot of people miss this. Remember what the 95% confidence interval is. It's equal to p hat plus or minus the margin of error. And what people were doing is they were putting p in sometimes. What is p hat? It's the sample proportion, right? It's the estimate for p. So it's 0.62 plus or minus 0.05. And so this is going to end up being, well, let me just write it as a straight percentage rather than the probability. It's easier. Okay, so it's just going to be 62% plus or minus 5%, right? So 62% plus or minus 5%. And so that's going to be 57 to 67%. That's my 95% confidence interval. Now, if we wanted a smaller margin of error at 3%, what would the sample size have to be? Well, I'm going to put in 3 for the margin of error, 100 divided by the square root of n. And this is going to tell me that n is equal to 100 divided by 3 squared. And that's going to be 33.33 squared. So let's see. Let me compute that out real quick. Okay, and the answer ends up being 1111.11. Now we're always going to round that up, okay? There's no such thing as 0.1 of a person, so we'd round that up, and our final answer would be 0.1112. Okay. Well, in this case, it's not people, it's stores, but we still can't have, a fraction of the store. So this is how many stores the employee would have to sample or survey if he wanted a margin of error of 3%. This is a good problem to practice over again, especially in preparation for the exam. And as I said, I will give more problems like that on the practice exam that I send out on Friday. if you have any questions, I would, recommend that you ask me, because this is the hardest part. But once you get it, it's really pretty easy, because it's just working with a normal distribution, which I think most of you know pretty well. All right.